Good evening, everyone. I am Paul Atani Gabion, and I'm here to report about the unit hydrographs of durations. So, unit hydrographs of different durations. The lack of adequate data normally preludes development of unit hydrographs covering a wide range of durations for a given catchment. Under such conditions, a DR unit hydrograph is used to develop unit hydrograph of differing durations ND. So, kung different durations sa gani ang unit hydrographs, mo na siyang ND na. Ikan ra po na dyan sa DR unit hydrograph. There are two methods that are available for this purpose. First is the method of superposition and the S-curve. So, the method of superposition, if a DR unit hydrograph is available and it is desired to develop a unit hydrograph of NDH, where N is an integer, it is easily accomplished by superposing N unit hydrograph with each graph separated from previous on by DR. So, mas masabtan na ni sa example. So, the next method is the S-curve. So, if it is desired to develop a unit hydrograph of duration MD, where M is a fraction, the method of superposition cannot be used. So, kung MD gani ang unit hydrograph, ang duration sa unit hydrograph, mo nang dito magamit ang kuan ka ng S o kadtong superposition. So, a different technique known as the S-curve method is adopted in such cases, and this method is applicable for rational values of M. Also known as S-hydrograph is a hydrograph produced by a continuous effective rainfall at a constant rate for an infinite period. It is a curve obtained by summation of an infinite series of DH unit hydrographs spaced D-H apart. So, you can see in the figure 6.16, it shows such a series of D hydrographs arranged with their starting points D-H apart or DR apart. At any given time, the ordinates of the various curves occurring at the time coordinate are summed up to obtain ordinates of the S-curve. A smooth curve through this coordinate results in an S-shaped curve called the S-curve. So, kung di nagikan ang S-curve sa makita sa figure kung bisa nagikan ang S-curve. So, this S-curve is due to a DR unit hydrograph. It is an initial steep portion and reaches a maximum equilibrium discharge at a time equal to the first unit hydrograph. The average intensity of ER, or the effective rainfall, producing the S-curve is 1 over D, centimeter per hour. And the equilibrium discharge, which we are given an equation, QS, so which is the discharge, is equal to quantity of A over D times 10 raised to 4 meter cube per hour. So, where A is the area of catchment in kilometers squared, and the D is the duration in hours ER of the unit hydrograph used in deriving the S-curve. So, construction of S-curve. By definition on S-curve is obtained by adding a string of DR unit hydrograph, each lagged by hours from one another. Further, if TB is equal to base period of the unit hydrograph, addition of only T sub B over D unit hydrographs are sufficient to obtain the S-curve. However, an easier procedure based on the basic property of the S-curve is available for the construction of S-curves. So we are given a simple, easier and simple equation, which is kining equation 6.8, which is kining u times t, or time, is equal to s times t minus s to the quantity of t minus d, or ds times t is equal to u times t plus s to the quantity of t minus d. The term s to the quantity of t minus d could be called as S-curve addition at the time t, so that ordinate of S-curve at any time t is equal to ordinate of TR unit hydrograph at time t at S-curve addition at time t. Note that for all t lesser than or equal should be lesser than or equal to t, and s to the quantity of t minus d is equal to 0. So we are given an example problem for the superposition method. So example 1. The ordinates of a 6R unit hydrographs are given. So makita na to sa table. Kita na to sa table nga given ang time and the ordinate of 6R unit hydrograph. So muna kini sila, sumpayaran na sila. So in answering this problem, kailangan na ito tabular method, tabular, para mas dali ra na to answeran and mas masabtan. So the problem is derive a 12R unit hydrograph for the catchment. So sa solution mo na yung sa column 1, makita na to ang katong given nga time nga 0, 6, 12, 18, 24, so on. So sa column 2 is the ordinate of 6R unit hydrograph. So mo tong sa 6 hours 20, sa 12 hours 60, and sa 18, 150, and so on. So sa column 3, ordinates of 6R unit hydrograph lagged by 6R. So lagged by 6R man sila. So mag-start ta sa 6 sa hour 6. Manang 0 dito 0 ni dire sa 6 hour. Sa the next is 12 is ang 20. Mura gyapon ang gamiton nga mga given katong kaning sa column 2 nga 20 meter cube per second, 60 meter cube per second. Mura gyapon gamiton dire. Pero dire lang ka mag-una sa 6 hours since it is lagged by 6 hours. The next is the column 4. Sa column 4, we need kailangan na nato i-add ang column 2 o column 3. So manang makuha na to nga dire 0 man sidya mo ng 0. Dire sa 6 hours is 20 plus 0 manang 20. 60 plus 20 mo ng 80 sidya, and 150 plus 60 is 210, and so on. Meter cube per second gyapon na sila ilang unit. And ang gipangadto is 12R unit hydrograph. So the ordinates of 12R, to find the ordinates of 12R unit hydrograph, kailangan na nato divide ang column 4 sa 2 since column 3 o kaduha ra si Jagi kaduha ra ang 12 gi lagged since 6 si Jaga 12 ni dayon. So mo nang 2 divide 2 ra si Jaga. Kung kuan pa ni si Jaga kung by 4 lagged by 4, so katuloon man ang 4 para imong 12, so mo nang divide 3 si Jaga. So dire kay 6 man kaduha ra man para ma 12, mo nang divide 2. So para sa column 5 ang C4 kintay 20 C4 20 sa C4 20 siya divide og 2 manang 10 manang dire 80 dito ang C4 kay 80 man divide 2 manang 40 and so on apil ang diri pod sa kilid sumpay ni sila sa hour ni sila time kini time mo na ilang ordinate sa 12-hour unit hydrograph 41 para sa 54 nga time 56 and so on. So we have another example po sa 4 S-curve. So the question is, the problem is derive the S-curve for the 4-hour unit hydrograph given below. So given na po ang atong time nga 0, 4, 8, 12, 16, 20, 24, o 28. Ordinate of 4-hour unit hydrograph which is in meter cube per second 0, 10, 30, 25, 18, 10, 5, and 0. So, mo gyapon siya na sila similarities sa katong superposition but kini adjay addition. Tabular method gyapon sa solve sa problem para dali. Moto kani time in hours mo ning katong given ja ang second column is katong ordinate of 4-hour unit hydrograph mo ra gyapon katong sa given kani sa babaw. So 10, 30, 25 and so on. Sa kining sa S-curve addition nigpangita nig-solve aning kining 0, 10, 40, 65 nani sa jay gamiton nato nimo ang equation nga 6.8 is kani mo nimo gamiton imo ning solution sa inigkuha sa S-curve addition and sa dong sa column 5 nga column 4 nga kuan kanang S-curve ordinate. So mo na to sa inigkuha sa S-curve addition. So at I is equal to 4 hours ordinate 4-hour unit hydrograph is equal to 10 meter cube per second since kani mo ni katong given. Mo ni given da cause S-curve addition is equal to ordinate of 4-hour unit hydrograph at t time is equal to 4 minus 4. Ang kining 4 basta is kining 4 hours. Ang kining gi-minus nga 4 is kaning 4 ordinate nga 4-hour unit hydrograph. So is equal to 0 sida. So ang atong S-curve sa 4 hours, S-curve addition sa 4 hours is 0. Diyan ikuha nimo sa S-curve ordinate mo na to gamiton nato nimong 6.8 nga equation. So i-add ra man to. So i-add nimo ang kining 10 kining given nga 10 meter cube per second plus 0 nga S-curve addition. So ang kaning sa ikuha nimo sa S-curve ordinate kay imo rang i-add ang 1 column 3 og column 2. So mo to. Anja kani kinapod parehara ni sila ang paagi kini kay sa at t is equal to 8 hours. So ordinate of 4-hour unit hydrograph gapon is equal to 30 meter cube per second mo ning given gapon. So S-curve addition is equal to ordinate of 4-hour unit hydrograph at t is equal to 8 kay 8 hours. Anja minus 4 nga 4 gapon sila nga unit hydrograph. 4-hour unit hydrograph. So equal siya sa 4 hours. Anja ang 4 hours is kiba man ta nga ang 4 hours is kadtong kani 10 meter cube per second. Mo na siya nga equal siya ani. Ang 4 hours is equal to kini nga 10 meter cube per second. So inikuha na to sa S-curve ordinate, gamiton niyo po na tong equation nga 6.8. So 30 kay ang katong sa column 2 is 30. So kini given column 2 plus 10 nga kini kinakuha na to nga S-curve addition mo nang 40 meter cube per second ang atong kuha. 8 hours. Moro gyapon paagi diri. And this calculation is repeated for all time intervals till t is equal to base with of unit hydrograph is equal to 28 hours. So, mo ni siya atong gi-fill up sa itong nakuha na nga solution, nga answer solution, ato rang gi-fill up siya. So, mo to ang kaning condition katong nakuha, ang kaning is kanang column 4 or kini addition ra siya sa column 2 ug 3. Mora ni sila. Manang 0 kini kay 10 plus 0 manang 10. 30 plus 10 manang 40. And so on. Yan si J plot pero wala nang gi-appeal kay dali nang siya i-plot ra man nimo. Mora jud ko. Next topic is use and limitations of unit hydrograph. So use and limitations of unit hydrograph are of great use in the development of flood hydrographs for extreme rainfall magnitudes for use in the design of hydraulic structures. Extension of flood flow records based on rainfall records. Pwede po na siya magamit. And kuni po, development of flood forecasting and warning system based on rainfall. Other is unit hydrographs assume uniform distribution of rainfall over the catchment and uniform intensity during the duration of rainfall exists. These two conditions are never satisfied. Under conditions of non-uniform areal distribution and variations in intensity, the unit hydrograph theory can still be used if the areal distribution is consistent between different storms. So, masabot naman siguro na to. And the next is the size of the catchment imposes an upper limit on the applicability of the unit hydrograph. So because the size of the catchment imposes an upper limit on the applicability of the unit hydrograph theory, because the center of the storm can vary from storm to storm, and each of these storms can give a different DRH. DRH is the direct runoff hydrograph under otherwise identical conditions in very large basin. The next is the upper limit for use of the unit hydrograph method is 5,000 km squared, and the lower limit for the application is 200 km squared. There are other limitations to the use of unit hydrographs. So first is the precipitation must be from rainfall only. Snowmelt runoff cannot be satisfactorily represented by the unit hydrograph. The second is the catchment should not have unusual large storage in terms of tanks, ponds, large flood bank storage, and etc., which affect the linear relationship between storage and discharge. If the precipitation is decidedly non-uniform, unit hydrographs cannot be expected to give good results. So, in the use of unit hydrographs, atong kanang induman nga, this is not very accurate because ang ijang result, dito mag-expect nga ang ijang result kay accurate. That's all.